Short notes on construction materials. In this video, we'll be seeing cement. Cement is a grey color powder which has four major constituents. It is named as Box compounds. The first one is tricalcium aluminate. It gives very fast reaction when added with water. It is also known as flash set or quick set. Here, hydrated C3A does not contribute to strength. The heat of hydration for C3A is 865 joule per gram. And second parameter is your C3S, nothing but your tricalcium silicate. Here, it contributes to early strength gain. Up to 7 days strength is due to the presence of C3S. It is most probably preferred in cold weathering conditions. Here the heat of hydration is high. And next is your C2S, dicalcium silicate. Here the hydration starts only after the 7th day. Here the heat of hydration is low. Here later strength is being contributed, which means here already we have seen that hydration starts only after 7th day. So 7th day till your 20th day, the hydration process that gives your later strength. Last component is your C4AF, your tetracalcium aluminoferrite. Here it hydrates very rapidly and no contribution in strength is being observed. So here the heat of hydration is 420 joule per gram. The components have been shown in the form of a pie chart here, where alite, that is C3S, is about 30 to 50 percentage, and belite C2S is about 20 to 40 percentage, and cellite C3A is about 8 to 12 percentage, phthalate C4AF is about 6 to 10 percentage. The orders to be noted here are rate of hydration and heat of hydration. For rate of hydration, C4AF is greater than C3A, greater than C3S, and again greater than C2S. For heat of hydration, C3A is greater than C3S, is again greater than C4AF, which is again greater than C2S. Just simply to remember the first one and just take the first component C4AF to your third place here. Remaining all remains the same. And next is your testing of cement. There are some basic tests for cement that are being conducted in the laboratory. The first one is your fineness. Fineness test to evaluate the fineness of the particular cement that we are using. It is investigated through the sieve analysis, which gives us the grain size distribution of cement. And the second is fineness could be determined using air permeability method or your Wagner's turbidity method. This both will give you the specific surface area or simply the SSA of cement. Next is your consistency test, that is determined using your Wickets apparatus, and your setting time, that is your initial and the final setting time, is also determined using your Wickets apparatus. Here your initial setting time should not be less than 30 minutes and your final setting time FST should not be greater than 600 minutes. Next is the soundness test. Soundness test is nothing but investigation of change in volume of the content. So this is investigated through your Le Chatelier's apparatus. Next is your specific gravity. So specific gravity is determined using Le Chatelier's flask. For OPC, specific gravity is 3.15. And next is heat of hydration. You call it as HOH. It is nothing but generally an exothermic reaction investigated through the calorimetry or vacuum flask apparatus. For OPC, for 7 day, the HOH is less than or equal to 65 calorie per gram, and for 28 days it is less than or equal to 75 calorie per gram. And next is your compressive strength, investigated using your compression testing machine. Here the cube size is 7.06 centimeter cube, and the ratio of 3 day to 28 day strength will be more or less equal to 1/2, and your 7 day to 28 day ratio will be more or less equal to 2/3. The tensile strength is investigated through your Brickett's test, or it's simply called as split tensile strength. Next is types of cement. The first one is OPC. It's nothing but your ordinary Portland cement. It has three different grades. One is your 33 grade, 43 grade and 53 grade. And second one is your rapid hardening cement. Here the C3S is greater than your C2S. The rate of early strength gain is high in this condition, and it is generally used for the formwork or repair works. Your third cement is your low heat cement. Here C2S is greater than C3S. Rate of strength gain is less in this cement. The strength is more or less equal to that of OPC strength, and also the heat of hydration is less. The fourth one is your blast furnace slag cement. It's nothing but generally a glassy granular in structure, and rapid quenching happens here. What happens when your blast furnace slag is added with water? We get a granulated blast furnace slag. GBF is nothing but it's made up of the oxides of lime, silica and alumina. The fifth is PPC. So PPC is nothing but Portland pozzolana cement. It's nothing but calcium oxide added with pozzolana plus water gives you the calcium silicate hydrate gel, which you call it as the CSH gel. It's majorly used for the mass concreting. Here the heat of hydration is low and the early strength is also low. Your sixth cement is your super sulfate cement. Here the combinations are nothing but cement constitutes of 80 to 85 percentage of granulated slag, 10 to 15 percentage of your calcium sulfate and 5 percentage of cement clinkers. Here by lowering the C3A tends to increase the sulfate resistance of the cement, and it has low heat of hydration, preferably used for marine work constructions. The next type is the white Portland cement. It has the proportion of iron oxides, so under limited circumstances. Next is your high alumina cement. Raw material are bauxite, limestone, silica, iron oxide. The initial setting time is equal to 3 hours and the final setting time is about 5 hours. Here the heat of hydration and the early strength both are high, and it gives high chemical resistance. So next is your last type of cement is your expanding cement. Here mixing sulfoaluminate in your cement gives you the expansion in cement. It is generally used for eliminating the shrinkage cracks in cement. The treatment of expansion joints for grouting, we use expanding cement.